In our last problem, we talked about how long the cannonball stayed in the air. Now, I want to go down and calculate how far, what is the distance, the cannonball will reach. Okay, now remember, the x component, the acceleration of the x component remains constant. So the acceleration equals 0. Okay, so if we integrate up twice to our position function, we are going to get our initial position, which we are going to safely assume, we can safely assume that we're starting at 0. So our initial position is equal to 0 plus our initial velocity, which we know our initial velocity, we calculated it here in the x component, is the cosine of 30 degrees times 30. Okay, so the cosine of 30 degrees, times 30 plus our acceleration, 1/2 our acceleration squared, or delta t squared. My apologies. Alright. We knew, since I set up here, our acceleration remains constant. We know our acceleration is equal to 0. So we can go back down here in the x component and plug in our acceleration equal to 0, which zeroes all of this out right over here. Okay. Now, with that being said, we can calculate our position. This, I forgot, is the change in time. We multiply it by the change in time because we integrated it up. So now, with that being said, our position function is going to be equal to our cosine of 30 degrees times 30. Cosine of 30 degrees is square root of 3 over 2. If you don't remember that, you can plug it in a calculator and you'll get 0.88 something times 30. Okay, these cancel with this, gives us 15 roots of 3 meters per second times our change in time, which is 3.06 seconds, and seconds cancel with seconds, okay, which we will get, okay, equal to our position in the x direction equal to, alright, so square root of 3 raised to the half power, which is the square root of 3, equals 1.73 times 15, okay, times 3.06 seconds, 3.06, okay, equals 79.5 meters, 79.5 meters. And I know it's meters because I had meters left up here. So this is our ending position after 3.06 seconds.